Okay, so today we are going to start covering percent composition. Yesterday we finished out, we did some practice on molar mass, converting moles to mass to moles using grams. Today we're going to pick up on percent composition. So your warm-up for today, what I would like for you to do is we're going to determine the percentage of students in the class. What percentage of students in the class have a birthday in each month? So you're going to have to figure out amongst each other what percentage of students have a birthday in January, what percentage has a birthday in February, what percentage has a birthday in March, and so forth. Just to give you a hint, the easiest way to do it is figure out how many students are in class total, and then ask around to find out how many students are in class for each month, and then you can find the percent. Okay? Go.
Okay.
And this is what's on your warm-up sheet.
It's 17 students.
And you need to find out who birthday in what month.
How many students got a birthday in January? 1, 2, 3, 4. 4 out of 17.
February.
We're going to go back through and put it in percent once you figure out how
How
many.
many?
Oh, she's going for 4 out of 17.
How many in February? 1.
Oh, really?
We gotta do the whole year?
Mm-hmm.
March.
Oh.
January, February, March. How
March.
many birthdays in March?
Nobody.
None.
0 out of 17.
April.
I'm not a student.
2.
2 out of 17.
May.
May.
2.
January, February, March, April, May, June.
2.
July. I got one.
How many in June?
2.
2. 1 out of 17 in July. January, February, March, April.
August.
Zero.
November. I mean October. September. Girl.
One.
October. 1, 2.
2.
Okay, so to find percent, what was November? 1. So to find percent, how do you find percent? How do you calculate percent for anything? What do you do, Erica?
Divide the fraction, then times by 100.
Divide the fraction, then times by 100. You're welcome. Thank you, Yvonne, please. You're welcome. Divide the fractions and multiply by 100. You got one. You know, my first year teaching, I worked real scared. But now, you have it all
Divide the fraction by 100.
You divide the fraction and then times 100. It got be
How do you find what? I'm from here.
What part of Fayette County from?
I'm not from Fayette County.
Ball.
I'm from Whiteville.
Okay, so if it's a decimal, we just put the number before the decimal.
Just round. If it's a decimal, you can round.
I got 23.5, so it's gonna be like 24%.
Yes.
Okay. I'm done.
You're done? Jocelyn is done. Okay, and remember, whatever number you get, if you multiply that by 100, it gives you the percent. Whatever number you get, you multiply that by 100 and it gives you the percent. What did you get, Jocelyn, for January?
24%.
24%. Justin?
Six.
February? 6%. What about March?
0.
0%. April?
12.
12%. May?
12.
12. June?
12.
12. July?
6.
6. August?
0.
0. September?
6.
6. October?
12.
12. November?
6.
6. December?
6.
6. Good job, y'all. So that's what we're doing today, but we're going to do the same thing with chemicals. So if I give you a chemical compound, then you'll tell me what percentage of each element is in that compound. So this is called percent composition. Percent composition, and this is where your notes should start. So we're going to start notes over here. Percent composition. Percent composition is the percent by mass. Percent by mass of each element in a compound. The percent by mass of each element in a compound. The percent composition, or the percent by mass, indicates the relative amount of each element present in a compound. So say we have H2O. Percent composition tells us what percentage of that compound is hydrogen, what percentage of that compound is oxygen. We know in a simple ratio it's a 2-to-1 ratio, 2 hydrogens to 1 oxygen. But if we needed to know based on grams, the percent composition would give us the amount in grams. Percent composition can be determined from its molar mass and also from its chemical formula. Percent composition can be determined from its chemical formula or its molar mass. So, to find the percent by mass. To find the percent by mass, you divide the mass. Bless you.
Thank you.
You divide the mass of the element by the mass of the compound and multiply it by 100. So just like in the warm-up, you took just the number of birthdays that was in that 1 month and you divided it by 12. It's the same thing with percent composition. So we'll find the molar mass and then we'll divide whatever that element's mass is by the molar mass, multiply by 100, and it'll tell us what percent of that compound actually makes up, what percent of that element makes up that compound. This is the equation to find percent by mass. So it's going to be mass of the one element that you're looking for, or mass of each element over mass of the compound times 100. I'll give you a couple of seconds to jot that down before I go on so that I'm not standing in front of you. Any questions about what we've gone over so far? What you have so far? We're good?
This I divide the mass of the
Element. Divide the mass of the element by the mass of the compound and multiply by 100. Okay, so steps to, I think most of you are over here. Steps to calculating percent by mass. So whenever you're calculating percent by mass, the very first thing that you do is you calculate the molar mass, which we know, we've done that a few times this week. Y'all did pretty good on that. The next thing that you do is you divide the element for, the mass. The atomic mass for each element by the molar mass. And then you multiply by 100 in order to convert it to percent. So we'll do the first example together, and then I have a couple of them for you to try. Okay, so example 1, what is the percent composition of potassium permanganate? Potassium permanganate is KMnO4. The very first thing that I do is find the molar mass for KMnO4. Can y'all help me with that? The molar mass of KMnO4. What do I do first?
Find K.
K, find K. What's the molar mass or the atomic mass of K?
39.10.
39.10, and I only have one of them, right?
Yes.
What do I do next?
Find magnesium.
Find the atomic mass for, okay, and what do I do to these two numbers, to those numbers? Add them. So what is the atomic mass for magnesium?
54.94.
54.94. Okay, and then what next?
Oxygen.
Oxygen, which is
16.00 times 4.
times 4. What do you get? $158.04. Can somebody confirm?
Yes.
That's what y'all got? Okay. So the next step is to find the percent of each element. Essentially what we are saying is we want to know what percent of potassium permanganate is actually potassium. What percent of potassium manganate is actually manganese? What percent is actually oxygen? We do that by following these steps. So first we'll take the molar mass of potassium. So we'll say 39.10 divided by the whole molar mass, 158.04 times 100. We'll do the same thing for manganese, 54.94 divided by 158.04 times 100. And then oxygen is 16 times 4, which is what? 64? 64 over 158.04 times 100. Can you guys tell me what you get once you do those calculations?
For K, I got 24.7.
Percent? Jocelyn is on it. For magnesium?
What is that? This is
54.94 divided by 158.04. What'd you get? Did you get it? 35%. And oxygen.
%40.
40%. Okay, and just as a checks and balance, all of these should equal 100. If you were to add up each percent, it should equal 100% of that total compound. If you say 40 and 24, that's 64 plus 35, it's right around 99, 100, between 99 and 101% if you take rounding into account. What I want you to do now is example 2 that's on the board. Determine the percent composition of sodium carbonate, Na2CO3, with the people that are around you, the groups. You can either work with the one person beside you or the groups that you are divided into. So I want you to do example 2. Talk through it, work through it, and let me know what you get.
How long you got to break?
I thought it was gonna hurt myself. Come on, Johnson.
And it's 14. It's what?
They can't be around. Can you scoot over a little bit?
C-O.
Thank you, sir. Appreciate you.
How we gonna be down? 3.
See out there.
Got 3 at the end. What about the 2? You do that. You gotta use N 8 times 2 because it's 93 times 4.
Oh, what did you get? Talk through it. Or with Eric?
I got 2.
She wasn't sure either.
I'm being stuck.
Oh, okay.
Just like you did on the practices.
Just have you and Tatiana working together, discussing with Erica. Make sure that you consult with somebody that is around you.
What you mean? For N 8, you can put 22.9, but if you ride, it's gonna be 23. I'll put 23. Oh, well, I did.
It should give you a really close answer. Your answer should be
I
really
got
close.
223.
Miss Cogdell.
Yes?
Okay, when we find NA, do we possibly put, to find a percent, do we multiply that to get it? Or we just right there?
So this is your first step. It's finding the molar mass. The next step is to do the percent for each one. So you divide the mass of that element. So you would say 22.9 times 2, because that's how much total sodium you had over the whole thing.
Is your 23 times 2 Yeah, no, divided by.
Yeah, it got a time, so it's the time at the top, then you divide. It's 21%. Yeah. Okay, see?
I got that.
How you be putting these stuff in the calculator every day?
Or sodium, since you have to
Give it all
multiply
away.
times 2.
I got 39.
30.
39%.
You have 40 plus
58.93
2.
times 3.
Yep, times. Very big. About 46. This was 63 plus 12 plus 40. Yep.
I got 79%.
Yeah, because I think that you got that because it is times 3. So that's your molar mass. Now, then you go through, and for each element, whatever you got here, it's supposed to be 46. So you just have 46 divided by this number times 100. And 12 divided by this number times 100. Are y'all good?
C2H5OH.
Dang. Could not speak.
Okay, if you have finished the group problem working together, please go ahead and try to do example 3 independently by yourself. So we all did one together, and then you try to do it working through it with someone else. And then example 3, try and do it by yourself so you can see if you have any questions.
So let us see too.
C2H508. What's up? Okay. So the very first thing that you do is find the molar mass. Remember how we found the molar mass? Where you look at your periodic table and you get the atomic weight. Once you got the periodic table.
Why do you say percent like this?
Okay. So once you find the atomic weight for sodium, since you got 2 of them, you take it anytime. Find the atomic weight for carbon. Find the atomic weight for oxygen times 3. Just calculate the molar mass for this whole thing. That's your first step. Your second step is for each individual element. Divide whatever the mass is together by the mass of the whole thing. So sodium is 23. So to find the molar mass, you that's step 1. I put it on the board. And then step 2 is find the percent. So you split them up. So you divided by what you found for the molar mass. 160. Find the molar mass of this compound. So that's adding up Na plus C plus O. So what you do is 23 times 2, but you got 2 of them. 23 times 2 plus C 12 plus 16 times 3. That's step 1. That's the molar mass. Once you get that step done, then I'll be back.
We get 52%.
I'm done with Cogdell.
Perfect. Perfect. Times 100.
What you get for, H5? 11.
Yep, so divide just one element by the whole thing, multiply by 100.
Would it be just 2%? Wow, yeah, you can put 2.
Okay, this is doing okay? So, okay, so you found, now add all of those up. And what's your add up 46, 12. Are you okay, so 160 is the molar mass. You want to write that down. Now you divide. So for Na, you say 46 divided by 106 times 100. 12 divided by 106 times 100. 48 divided by 106 times 100. What that tells you is what percent of this whole compound is sodium. What percent of this whole compound is you all find, that's good, Justin. Do y'all find this